So here's 3.2. It starts out with reviewing solving quadratics, which I'm not going to do. That we did a bunch of those with both solving by factoring and solving with the quadratic formula in either 1.0a or 1.0b, and that set of video notes is up on YouTube, so you can always just go and watch that if you need to. So then here we have the graph of a quadratic. It's a parabola. This one opens up. And so the first thing they're asking me for here is the vertex. And remember, the vertex is the turning point. So the vertex here would be -1, -4. And now since this parabola opens up, that vertex is a minimum. And then this is going to function the same way that it did when we were doing local min and local max. So this is a minimum of -4 at w equals -1. The domain of every quadratic function is always all real numbers. And then the range depends on two things. It depends on this minimum value or maximum if it opens down, because if your parabola opens down, then your vertex is the maximum. And then it also depends on which direction it opens. So if your parabola opens up, then your range starts here. This is the minimum, so it's the first value, and then it goes up toward infinity. Now, if your parabola opens down, then your vertex is a maximum. So then your range would be -infinity unto your y value of your vertex. All right, your w-intercepts, they are right here at -3 and 1. Your q of w-intercept is right here at -3. A parabola that's facing up is increasing on the right side of its vertex and decreasing on the left side of its vertex. A parabola that opens down is going the opposite direction. So on which interval is this increasing? Well, it is increasing from the vertex to infinity. That's the right side of the vertex, excuse me. And then it is decreasing on the left side of the vertex from -infinity to -1. And its end behavior, it's going up on both the left and the right. So we're going to say that as w goes to the right, q of w goes up, and as w goes to the left, q of w also goes up. And so if our parabola had been opening down, then these both would have been -infinity. So if we're given a parabola and asked to write the equation, we're going to put that equation in vertex form. Where HK is the vertex. So the vertex of this quadratic is right here at 1, 2. So this becomes y equals a times x minus 1 squared plus 2. And then the only other thing we need to do is find a. So to find a, pick any other point on the quadratic and plug in. So for example, I have a point right here at -1, 3. So I'm going to plug in -1 for x and 3 for y, and then I'm going to solve for a. That's going to be -2 squared, which is then going to be 4. Right, -2 squared is 4. And let's subtract the 2. and divide by the 4. They want decimals, so we'll say that A is 0.25. And so then the equation of this parabola would be K of W equals 0.25 W minus 1 squared plus 2. So that's this up here, just with the A value plugged in. Now, when you're graphing these in more, you only need 2 things. You need the vertex and any other point. So if you want to, you can graph this in your calculator and do second and trace to get to calc and use the calculator to find the minimum or the maximum the way that we did last unit. But I'm gonna find the vertex by hand. So to find the vertex by hand, you start with the axis of symmetry, which is x equals negative b over 2a, which in this case would be a negative 8 over 2 times 4. So my axis of symmetry is x equals negative 1. And then once you have your axis of symmetry, you plug that in, and that will get you the y value of your vertex. So I plug in the axis of symmetry to get the y value of my vertex. 4 times 1 minus 8 plus 3. So the y value of my vertex is also negative 1. So my vertex is at negative 1, negative 1. And then again, Moore only needs one other point in order to be able to graph this. So the easiest point to use is going to be the y-intercept, which is always just going to be this constant. So then you put your dot on your vertex, your dot on your y-intercept, and Moore will fill in the rest for you. Okay. So this next one looks a lot like the first one that we did together, only instead of giving me a graph, they gave me an equation. So I'm going to do the same thing that I just did to find the vertex. And I'm going to say, okay, the vertex would start at negative b over 2a. So that's going to be a negative 11 over 2 times 2. And again, they're asking for decimals here, so I'm going to make that 2.75. And then to get the y value of the vertex, again, I take that x value and I plug in. So I'm going to take the 2.75 and plug it in. Squared minus 11 times 2.75 minus 21. And again, you can totally use the calc function on your calculator if you don't want to do this by hand. Honestly, I think it's easier to just do it by hand versus graphing it and then having to do calc trace, but that's just me. Or calc min. And now I know this is a minimum because the a value is positive. So if you have a negative a value, then your parabola opens down. And if you have a positive a value, then your parabola opens up. So this would have a minimum. And then just like the one on the other page, it would be at 36.125 or of, excuse me, negative 36.125 that occurs at c equals 2.75. And then just like the other one, the range is all real numbers. The range of every quadratic is always all real numbers. There's no restrictions on the domain here. And then the range, since this opens up, would start at that minimum and go up to infinity. Okay, so to find the c-intercepts, we make k of c0. And so I need to solve this. I think I'm going to factor. So 2 times a negative 21 is negative 42. And I need two numbers that multiply to negative 42 and add to negative 11. So that's going to be a negative 14 and a positive 3. So I can GCF out a 2C. I can GCF out a 3. So then they have the C minus 7 in common. And then I'm just going to solve each one of these individually. So C, not plus 7. C minus 7 equals 0. Add the 7. So C equals 7. And then 2C plus 3 equals 0. So we'll subtract the 3 and divide by the 2. And negative 3 divided by 2 is going to be negative 1.5. And so again, if you wanted to, just like the ones that the polynomials that we did, you could graph this and do calc 0. But the K of C-intercept, so that's the Y-intercept, and then to find that we would make C0. So if I made C0, this term would drop out, this term would drop out. I'd be left with negative 21. And just like with the last one, since this opens up, it is increasing on the left side of its vertex and decreasing on the right side of its vertex. And also, just like the last one, since it opens up, my end behavior is that it goes up on the left and up on the right. So it's going to be as C goes to the right, K of C goes up, and as C goes to the left, K of C also goes up. Okay, so here we have the height of a NASA launched rocket, where T is the number of seconds since the rocket was launched. So assuming that the rocket will splash down into the ocean, after how many seconds will splashdown occur? So that means that I want to know, when is the height of the rocket 0? So then this would be 0 equals negative 4.9 T squared plus 298 T plus 108. And so I'm going to use the quadratic formula on this one. And so that's going to be T equals negative B plus or minus the square root of B squared minus 4 times A times C over 2 times A. And now I'm just going to plug into my calculator, honestly. So the numerator and denominator each need their own parentheses. So this would be 298 plus the square root of 298 squared minus 4 times negative 4.9 times 108 divided by 2 times negative 4.9. And then I'm going to press second enter. And I'm going to change this to a minus, plus and minus. And so my two answers Now they're asking me about a time. So I'm going to say time can't be negative. I'm going to throw that answer out. So my correct answer is 61.177. And then if they're asking about its peak, that means its vertex. So first we need to find the time at which it reaches its vertex using that negative b over 2a. So that's negative 298 over 2 times negative 4.9. So now that is the time at which it reached its vertex or its peak. And so to figure out the height at its peak, we would need to take this and plug it in.
Mama, shall we?
Yeah, I'm going to be in there to read to you in just a minute. Okay, baby?
Mom, shall we?
So then the height would be and this is, oh no, it's the next one that I'm thinking of. So that's my height. And then if we assume the rocket is launched from a launch pad, how high is the launch pad? So think about it. The rocket is sitting on the launch pad at the point when it launches. So that would be when T is 0. And so if T is 0, then that means this drops out, and I'm left with this 108. So that would be the height of the launch pad. Okay, and so for this last one, the quadratic regression, we do almost identically to how we did the linear regression. So you would go to stat and then edit. And if we look up, so I already have this listed in my calculator. So once it's there, you go to stat and then cal. And number 4 was linear regression. That's what we did last time. This time I want a quadratic regression. See it? Quadratic regression. So then my equation, which is what they're looking for here in this first one, is h of t equals negative 4.9 t squared plus 26.4 t plus 55. And so then how high will the object be 2.8 seconds after it's thrown? So I need to plug in 2.8. So it would be 90.504 meters. And then how long will it take to reach 5 meters? So 5 meters is a height. So you would have to say 5 equals negative 4.9 t squared plus 26.4 t plus 55. So I'm going to need the quadratic formula here, but before I can do that, I have to move this 5 over. So 50 on the end there. And so then in the quadratic formula, this will be negative 26.4 plus or minus the square root of 26.4 squared minus 4 times a negative 4.9 times 50 over 2 times negative 4.9. And again, just like before, I'm just going to put this in my calculator. Negative 26.4 plus the square root of 26.4 squared over time negative 4.9 times 50 divided by 2 times negative 4.9. Second enter. Change that plus to a minus. And so I have negative 1.485 or 6.873. And now, just like before, since I'm measuring time here, my answer can't be negative. So my last box here would be 6.873 seconds. Oops.